Great to see you here again. In this new video, I will talk about fast tracking, and we will apply what we learned in the previous video on an exercise. Before we start, please click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. My name is Luc de Ceuster, founder of the Ceuster Academy, and let's have a look at this new exercise related to fast tracking. When we look at the project, we look at a simple project, and we have the following series of activities and their precedence and duration. We are building a bicycle and we have 4 activities. A is to prepare the frame. There is no predecessor for this. We are preparing 10 frames, and the preparation of a frame takes 4 minutes. So the total activity time is 40 minutes. We prepare the wheels, front and back wheel of the bicycle. Every wheel set takes 2 minutes to prepare, so we also have 20 minutes in total. The next activity, C, we have to add the wheels to the frame, and here we have the 2 predecessors, A and B. It takes 2 minutes to add the wheels to the frame. For 10 bicycles, we have 10 times 2 minutes, which is 20 minutes. And finally, activity D, once C is finished, we can test the bicycles and they are ready for transport. Now, the first thing we have to do is to create the project diagram, the precedence diagram, and we have to identify the critical path. Let's have a look at the network diagram that I described in the previous slide, or I mean the precedence relationship. So we have activity A, where we do the frame of the bicycle 10 times. We have activity B, where I create 10 sets of wheels. And after this, I add the wheels to the frame. That's the third activity. And the final activity is where we test the bicycles. Now, when we look at the activities, we can say that activity A, the first activity, takes 40 minutes. We can see in the table that we basically have to do each frame in 4 minutes. So every 4 minutes I have a completed frame. We can do the same thing for the wheels. Here we have a total duration of 20 minutes. It means that every 10 minutes we finish one set of wheels. Adding the wheels to the frame also takes 20 minutes in total. Again, 2 minutes per frame to complete the frame. And finally, when the bicycles are finished, we're going to test the bicycles, which also takes 2 minutes per bicycle. We can call the activities, like I said, A, B, C, and D. It will be easier to work with those, or we can use a different code depending on the way you work in your organization. We can calculate the start and the finish, early start and early finish, and find the network diagram or find the critical path. We have the network diagram here already. It means activity A starts on 1. 1 plus 40 minus 1 is 40. So activity A finishes after 40 minutes. Activity B also has no predecessor, so it can start at minute 1. Takes 20 minutes. 1 plus 20 minus 1 is 20. So activity B finishes after 20 minutes. Now we can look at the early start of activity C, and we have to use the maximum early finish time of A and B, which is 40. We add 1 to go to the next period. So we see that activity C can start at minute 41 and will finish 41 plus 20 minus 1 is at minute 60. Test bicycle activity D can start the next period, so minute 61, and finishes after 20 minutes at minute 80. Now, basically, when we look at this, we can find the critical path, and we see that the critical path is A plus C plus D, which gives us a total duration of 80 minutes. Now we want to do something about this, and we are going to look at the principle of the, let's say, fast tracking. Now we have to look at the activities which we can fast track. And we have to concentrate on the critical path. And when we identify the critical path, the fast tracking has to be applied on that critical path. In our example, the critical path is given by the activities A, C, and D, and the total project duration is 80 minutes. In our case, we want to see what can we do, how can we reduce the project duration. Let's say 80 minutes is too much, but we want to find a better solution. And let's see how we can reduce this project most efficiently, the shortest duration in our case, when we are applying fast tracking. Now, when we look at the deliverables of activity A, we send them to activity C and finally to activity D. Now we can change the work order, and each time a deliverable is completed, it is forwarded to the next activity. Originally, we were doing it differently. We look at the 10 bicycles, the 10 frames that we had to prepare. We finish the 10 frames, and then we send it to the next step. We prepare the 10 sets of wheels, and we send it to the next step, and then we assemble them. We assemble all of them, and when all of them are assembled, we send them to the final step where we test the bicycles. But when we apply fast tracking, we can do it in a different way. We can do it in a better way. We're going to apply a step-by-step approach to see how we can apply fast tracking here. And what do we have? First of all, we have the first activity, which starts at period 1 for the first frame of the bicycle. It finishes at activity 4, at minute 4. We have the second activity, which starts also at minute 1, but the first set of wheels is already finished after 2 minutes. Once the frame and the wheels are ready, we can add the wheels to the frame. So we can do that once activity A is finished, so it's minute 5, and it takes 2 minutes, so it finishes at minute 6. And now we have the last activity where we test the bicycle. The wheels are finished. The wheels are added to the frame at minute 6, so we can do the testing in minute 7 and 8. So basically the first bicycle here is now completed after 8 minutes, where we had the first bicycle completed in the previous item a lot later. So basically we only had it there at 61 minutes. It's already a very big achievement, but let's see what are the next steps that we're going to do. So basically we do the same thing again, and what we see now is that the second frame is finished at minute 8. We can add the wheels at minute 9 till minute 10, and the bicycle is ready for testing at minute 10, and the testing is done from minute 11 to minute 12. So after 12 minutes, we have our second bike. So 4 minutes later, which is logical because every 4 minutes I have a new frame completed. Now we do the same thing here. We find the same numbers here. We have the third bike is finished, or the frame is finished after 12 minutes. The frame and the wheels are added after 14 minutes, and the bicycle is completely finished at minute 16. And we complete that, we continue that until we reach the last frame. And the last frame can be, or is worked on, is started on minute 37 and finishes at minute 40. We can also add there the numbers for the other activities. So we have the wheels added to the frame, and we see that we can add the wheels to the frame starting on minute 41, finishing on minute 42. We then do the testing. The testing of the last bicycle can be done at between minute 43 and minute 44. And here our project is basically finished. So we see that there is a big difference here. We see that the project is now completed in 44 minutes, where in the previous example, where we're just applying the classical precedence relationship, it was 80 minutes. So we save 36 minutes without working harder, faster, and since we're working at the same rhythm, we can in fact guarantee a higher quality, because quality is related to the speed that we do things. When we need the time, when we use the time well, we will see that we can in fact produce these bicycles with less issues. Let's now have a look at how this looks on the project schedule when I draw a new project schedule. And we start with the reviewed project schedule, where we have the activity A 10 times the frame. We have activity B, where we create the 10 pairs of wheels, and we start working on adding the wheels to the frame once we have 10% finished of the frames and the wheels. Now the last step here, we have the timing. We start with A at minute 1 and we finish at minute 40. We have to do those 10 frames. We cannot do anything about that. With the wheels, when we look at adding the wheels, we look at minute 1, and the last time that we should add or have the wheels prepared is minute 39 or minute 40. Can be the same minute. We can extend it, or we can just complete the wheels because those go faster. We can say we will finish the wheels in 20 minutes and we have some extra slack time. And once the wheels are finished, the person working on the wheels can in fact be allocated to some other activity if it would be necessary. There are different ways to deal with that. Now we continue here. We have, or we can start adding the wheels to the frame after minute 5, from minute 5, and we add the wheels till the end of the project, which is minute 42. That's the last time that we are adding wheels to the frame. And finally, we have activity D. Activity D can start also at minute 7, the moment we have the first frame completed. So the first frame with the wheels is completed at minute 6. So we can start testing the bicycles at minute 7. And basically what we have here is that everything will be finished at minute 44. So basically what we have here is in fact this improvement. We can also look at testing the bicycles. We can also change this. We can do it later because we only need 2 minutes. So we could start with testing the bicycles later, depending on how you will organize your project. That's in fact very important to see. Like I said, for activity B, we can start at 2 and finish at 21. So we can start a lot, let's say, earlier, or we have a different early finish and early start for activity B. Depends how you want to plan it. And we see that our first bicycle is already finished after 8 minutes and not 62 minutes. Now let's have a look at the conclusions and some remarks that we may have related to fast tracking. Now, when we look at the previous slides, we see that the project could be reduced with 36 minutes without increasing the work volume and pressure. It is very important when we look at other applications, when we are looking at crashing, we put more people, we try to do the activity faster. Here, when we look at fast tracking, we don't do the activity faster, we do it in a different way so that the overall efficiency increases. Now, we don't have issues related to quality because working faster or including risks, and when we try to push the people, it will reduce in reduction of quality. Fast tracking, like we did it in the previous example, does not have that disadvantage. Now, we have to also consider that when we look at the project, how we looked at it originally, and when we fast track, that we have to set up the project in a different way. Just imagine that the different activities are located in different places, in different locations. And it means that once we finish the 10 bicycles, we send them to a location. Now we have to do that bicycle by bicycle. and it also will lead to extra transport and extra cost. When we look at fast tracking in this way, when we try to reduce the duration of the project, we also have to consider how to change the setup of the project. These are things that are very important, but let's continue with the next video. But before leaving, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. I thank you very much, and I'm looking forward in our next video. Bye bye.